Hello, welcome. This is a one-take 2024 National 5 Maths Paper 1 run-through. First off, I'm a little bit worried that if you are here the weekend of the exam, that you're seeking some sort of reassurance if you've literally just done it, and I can save you some time and do that for free. There is literally nothing that you could have written in your National 5 Maths exam that will irreparably ruin your life. You are fine. You're the same wonderful person you are before you went in the exam, and you're still going to have a weekend full of fun. Think it's a long weekend. Enjoy getting ready for your next exam. But honestly, if you think it went terribly and you are just looking at this for reassurance, probably the best thing that you can do is just write a note to future you in 1 year's time who is getting ready for their maybe National 5 Maths again, maybe higher maths, just so you can kind of remember how you felt and look at that as motivation for revision for next year. Okay, let's jump in, let's do this. If you are here for the maths, then stick around. That's what I'm here for, I'm excited. Let's go. So starting off with 3 2/3 minus 1 1/4. Okay, currently they have different denominators, so I'm probably going to want to look for a common denominator. I'm going to deal with the whole number part first. So 3 minus 1 is going to give me 2, and then I'm still going to have 2/3. I'm still going to have to take away 1/4. A little mental check is that 2/3 is bigger than a quarter, so this is going to be quite nice. And then I'm going to change this into 2 and something over 12 minus something else over 12 using my lowest common multiple of 3 and 4. Okay, I had to times the 3 by 4 to get to 12, so I'm going to times the 2 by 4, and that's going to give me 8. I had to times the 4 by 3, so I'm going to times the 1 by 3, and that's going to give me 3. Okay, so now I have 2 and 8/12 minus 3/12, so that's going to give me 2 and 5/12. No simplification required. Have a quick look at the marks. 2 marks. Do I feel like I've done two marks worth of working? Well, yeah, I've done 2 lines of working, plus this kind of bonus. You're not getting a mark for doing 3 minus 1, sorry. But yeah, I feel like this is 2 marks of working. The fun fact, the marking scheme doesn't exist yet. They make it up after the exam so that they can include the common errors. So I will not be commenting on where the marks come from because we don't really officially know yet. Okay, next questione. We've got f of x is equal to x plus 3 squared, and we want to find f of 7. Okay, so this is some functions. All we're going to do here is just replace x's with 7. So f of 7 is going to be 7 plus 3 squared. And at this point, it just becomes a BODMAS question, an order of operations question. So 7 plus 3 is 10, and 10 squared is 100. That is a nice first page of this exam. Feeling good about this. Okay. Next, let's go. Expand and simplify. And they've put in, so you've got a binomial and a trinomial, 2 times 3. So the key here is to make sure that every single thing in this, in either of the brackets, but in the bracket with 3, is multiplied by everything in the bracket with 2. So I'm going to do x times all of the things and 1 times all of the things. There are loads of different methods for this, so you just pick the one that you like. So first of all, x times x squared is going to give me x cubed. X times minus 4x is going to give me minus 4x squared. And x times 5 is going to give me positive 5x. On to the multiplying by 1. Yes! Love multiplying by 1, especially in an exam. This is so nice. So x squared minus 4x plus 5. Okay, now it is time to gather together those like terms. X squared, sadly, no buddies. X cubed has no buddies, so that's just going to be on its own. X squared does have buddies. We've got minus 4x squared plus x squared. Remember, the negative belongs to the thing that comes after it, so we're going to have minus 3x squared, and x's, we've got plus 5x minus 4x, resulting in a whole plus x, invisible one. And constants, again, nothing to compare with that, no like terms, no buddies, so that's just going to be plus 5. Cool. And then just do a quick run through check again, make sure everything's actually simplified. Yeah, that looks good. Does it feel like 3 marks worth of work? If they're giving out a mark for multiplying by 1, that's kind of cool. But I think that might actually be the case. Okay, now we're onto some vectors. So we haven't seen vectors in a couple of years. It's a strong return from the vectors in the National 5 papers this year. So we've got A is a column vector 3, 4, minus 1. B is 5, 3, 2. And we want to find the resultant vector 3A plus B. Vector arithmetic works exactly how you would like. So 3A is just 3 times all of these things. So we're going to have 9, 12, and minus 3. And oh no, look at that bracket. The B is just going to stay exactly the same. 5, 3, 2. Okay, and then we just add them together. 9 plus 5 is 14, 12 plus 15, minus 3 plus 2 is minus 1. Now we don't know for sure, but I feel like they might be quite insistent on having the brackets around this. I feel like that's probably going to be one of the main ways that people frustratingly lose marks here. Okay, we have, what have we got here? Median and interquartile range. Let's take a sip of, I hope you've all been enjoying this wild, I'm not sponsored by Iron Brew by the way, but this wild berry slush Iron Brew, I have been loving it. It's so good. Okay, so the price in pounds of cameras on display in a shop are listed below. Various prices, they are currently in order, so that's quite nice. Calculate the median and interquartile range of these prices. So now I want to really look close and make sure, are they actually in order? Yes, they are in order. I've got 6 pieces of data, so the median is going to fall in between 190 and 210. It's going to be bang in the middle, but there isn't a number there. So the median is going to be the average of both of these. I mean, I could add them up and divide by 2, but hopefully you can see that in between 190 and 210 is 200, because it's 10 below this, 10 above this. So the median is going to be 200. If you add them up, I mean, 190 plus 210 is 400. Divide by 2, you still get 200. Okay, and the interquartile range of these prices. So for this, we will need to find Q1 and Q3, the quartiles. So looking to the left of my median, which will be Q2, I can identify that 160 is going to be Q1. It's like in the middle. And then looking to the right of the median, in the middle, I have this 230. So that's going to be quartile 3, Q3. Do you need to write them out? It's definitely going to be important to write out that what sum you're doing. So the interquartile range, IQR, is going to be Q3 minus Q1, which is going to be 230 minus 160, which is what, 70? Yeah. Now, there is a solid chance that many people have worked out the semi-interquartile range by halving this, in which case you've probably lost a mark, frustratingly. Yeah, happens. Okay, so on a website, a sample of camera prices have a median of 195 and an interquartile range of 73. Oh no! Make 2 valid comments comparing the prices of the cameras in the shop on the website. Okay, so there's a little bit of interpretation that needs to go on here because they don't really want an actual explanation. They want one statement on the median and one statement on the interquartile range, but you can't really mention median or interquartile range without, you have to say what it actually means, what information you're getting from that. So let's see, the median is higher in the shop. So what could we say about the median being on higher? We could say something like on average, the prices in the shop are higher. Okay, and then what can we say about the interquartile range? So in the shop it's slightly lower. Oh, ever so slightly lower. £3. Okay. So if it was drastically lower, I would feel very happy saying that the prices in the shop are more consistent. Maybe we should even put in higher than online. But these are so close. But I think even though it's just very slightly, still we're gonna put in the prices in the shop are more consistent. Or I could say something like consistent, fact check me. Yeah, we could say something like the prices on the website are more varied, but this is so close. I'm really interested to see what the marking scheme comes up with that. I think likely they'll take saying that 70 makes it more consistent, and they'll probably also take that they're roughly the same in variation or consistency. I don't know, interested. Good to see what happens from that. Okay. Nice. Onto some standard surds. Let's do this. So root 75, I'm going to kind of run through in my head what square numbers is 75 divisible by. It's divisible by 25, yay! Okay, and so root 75 would be root 25 times root 3 minus, and then root 3 is a prime number, we can't break it down any further. So root 25, we have an answer for that, it is 5. So this becomes 5 root 3 minus root 3. Now this is wonderful because when it comes to adding and subtracting surds, you need the thing under the surd house to be the same. Because it's kind of like algebra, you know, you can't do 5a minus b, but you can do 5a minus a, you would have 4a. So in that similar vein, we're going to have a 4 root 3. Coolio. Okay, question 7. So in these semi-structured papers, they do always leave you enough space, but sometimes they leave you extra space, so just don't let that fool you, because I think there's going to be some questions that have more space. I think we are going to need all of the space for this one though. So we have 2 equations and we have 2 variables. Wonderful, that means we can probably solve this. So I'm going to label this first one equation 1 and the second one equation 2. Now I'm going to look as to what matches here. Let's see. My first instinct is I want to multiply 1 by 3 and 2 by 2 so that the p's match up. I do think that that's going to end us up with a double negative situation. Here we have 1 minus and 1 positive for the r's, so that might be nice. Yeah, let's do that. I'm going to make the r's match up. You can get the marks either way, it will be fine. So I'm going to do equation 1 multiplied by 2, which is going to give me, and I'm leaving like a good gap so I know that that's not really involved in the equation. So that's going to give me 4p minus 14r is equal to 22. And then I'm going to do equation 2 multiplied by 7, because I want these to both be 14. So that's going to give me 21p plus 14r is equal to 28. I am just going to add these equations up piecewise. It might be quite nice to kind of label them like, okay, this is now equation 3, this is equation 4, and I'm going to do equation 3 plus equation 4. but I think it's fairly clear what's going on. So 4p plus 21p is going to give me 25p. And then these two are going to cancel out. Minus 14r plus 14r is just going to give me 0. And 22 plus 28 is going to give me 50. And this works out quite nice. I've got 25p equals 50. Dividing them both by 25, I can say that p is going to equal 2. Okay, and then, separate sum, I'm going to substitute p is equal to 2 into, and I get to pick whichever of the first two equations I want. I mean, you could use equation 3 or 4 if you like, but the numbers are bigger. So, what am I going to pick? I think I'm going to go with equation 2. It's all positive, the numbers are smaller. Why make life more difficult? So this is now going to become 3 times 2 plus 2r equals 4. So 6 plus 2r equals 4. I'm going to run slightly out of space. 2r is going to be minus 2, and I'm just going to say r is going to be minus 1. Sorry, I did 2 steps in one. Okay, it's a mean one for 3 marks, but sigh. Right, let us go. Question 8. Do not be scared of the trig graphs. It'll be fine. Look, they're just little 1 mark questions. It's going to be okay. So first of all, we've got a cos bx, and I have a look at this, like, does this recognize in my brain as a cos graph? Yes. So it hasn't really been like shifted or turned upside down or anything. This looks like 2 cross graphs merged together, and then I just need to know what effect A and B have on the cos graph. So A is the amplitude. The thing that goes before the cos is going to be the amplitude, and that affects the height of the graph, the stretchiness. Normally, a cos graph goes to 1. This one goes to 7, and that leads me to believe that A is equal to 7. For B, in here, just before the x, that affects the frequency, or how often the graph repeats in between 0 and 360. Normally, a cos graph starts at the top, goes pew, down and back up again. This one, we got so it's doing 2 in the place that it would normally do 1. And so I'm going to say that B is equal to 2. Always check that they've actually shown the graph between 0 and 360. Sometimes they're cheeky and they do it between 180 or something like that, but this is quite nice. This is standard. Okay. Now, this question looks very similar to previous questions which have come up, especially in the applications exam. So, nice little bit of crossover here. In a car rally, competitors start at different times, blah, 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 blah. The scatter graph shows the relationship between the length of the time they have been driving in t minutes and the distance to the finish line in d kilometers. So, oh no, look at that. They've put t on the x-axis. That's mean. Okay, it's fine. The maths is still exactly the same, but like, I feel this makes interpreting the graph a little bit more difficult, but you can see as time goes on, the distance from the finish line gets closer and closer to 0. Does nobody actually finish? I would, okay, you know, are they gonna ask that? I'd like to know when someone actually finishes. Okay, a line of best fit has been drawn. Point A represents a competitor who has been driving for 3 minutes. Oh yeah, it's like at a point in time. So there will come a time where they all hit 0. And it's 26 kilometers from the finish line. Point B represents a competitor who's been driving for 10 minutes and is 12 kilometers from the finish line. Let's get that information on the graph. So A, they've been going for 3 minutes and they're 26k away. They've at least put it in like XY order, so that's nice. So 3 minutes and they're 26k away. They've been driving for 10 minutes and they're 12k away. So this is 10 and 12. And then just kind of like ignore the context for a second and make sure that these points look like what they represent. Like, this has an x coordinate of 3 and this has an x coordinate of 10. Yes, B is further along. This has an x coordinate of 12 and this has an x coordinate of 26. Yes, this one is higher up. This checks out. Find the equation of the line of best fit in terms of d and t. That's going to catch plenty of people out. If you don't put it in terms of d and t, if you just leave it as x and y, you're probably going to lose the last mark. But we don't know because the marking scheme isn't out yet, but probably. It's okay to work in x and y if you want, if that's what you're used to, but then make sure that you go back and change it to d and t at the end. Okay, so we have 2 points, and to work out the equation of a line, we need two things. We need a gradient and a point on the line. We don't necessarily need it to be the y-intercept. So let's get our gradient first of all. M, which stands for gradient, obviously, is going to be y2 minus y1 over x2 minus x1. Remember, y to the sky, x to the dex, don't get those mixed up. Okay, so looking at my y-coordinates, do you know, if there is a chance of you getting these mixed up, literally go through and write down, like it goes in alphabetical order. This is going to be your x, this is going to be your y, this is going to be your x, this is going to be your y. It doesn't matter which way around, like which one's coordinate 1 and which one's coordinate 2, as long as you are consistent. So this is, we're just going to say this is the first coordinate, this is the second coordinate. Label them if you are in danger of messing this up. So y2 minus y1, we're going to have 12 minus 26. In this case, there is no way to keep it all positive. Over x2 minus x1, so we're going to have 10 minus 3. So 12 minus 26, what are we on there? 8 plus 6, 14. So minus 14. Over, oh that's nice, 7. So minus 14 divided by 7 gives us minus 2. Quick time to check. A negative gradient, I'm expecting the line to go down the way, and hey-oh, this line is definitely going down the way. It's all working out, it's all looking good. Okay, so now that I have my gradient, and I have not 1 but 2 points on the line that I could pick from, I'm ready to fire this into my y minus b is equal to m open brackets x minus a formula. Or there is a way to use the y equals mx plus c formula where you substitute in and work out what c is. That also works. So let's go. Which point am I going to pick? I quite like the 10 and the 12, especially because I've got a 2 for the gradient. I don't know, it just seems like nice and even, and these numbers are... I can't say that they're lower, but they're closer together. Anyway, it makes no difference. You pick whichever one you like. So we're going to go with y minus, and again, yet again, is going to go in alphabetical order. So I've picked this point. This is going to be A. This is going to be B. So y minus B, y minus 12 is equal to, use my m from before, minus 2, and then in the brackets, x minus 10. Okay, now we're going to multiply this out and rearrange a little bit just to make it look neater, and because we live in fear of that 1 year that the marking scheme that said that you literally had to do that. Okay, so we've got minus 2x, minus times minus, plus 20. This looks nice. I'm going to move the 12 over to the other side by adding 12 to both sides. So I get y is equal to minus 2x plus 32. This is a nice equation. Does that look like it's going to make sense? Minus 2, so for the gradient, it's heading down the way, yes. Does it look like the y-intercept would be somewhere in the 32 range? Well, this is 26, so like, yeah, this seems good, it seems fine. I'm happy with this. Okay, another competitor, underdog, has been driving for 7 minutes. Use your equation! From part A, to estimate the distance the competitor is from the finishing line. Okay, so my equation from part A is y equals minus 2x plus 32. Y equals minus 2x plus 32. It's nice on your marker if you kind of write that again. It's totally unnecessary, but you might have noticed that these are on different pages, which means when the marker comes to mark them, they'll be on different pages, and they'll have to flip, excuse me, hiccups every day. You'll have to flip back and be like, oh, what did they have for their equation? Because whatever your equation was, if you use your equation and substitute correctly, you're gonna get, whoa, hold on, stop, no, ah! I'm about to lose a mark. And I even underlined this in terms of D and T. Okay, so my X is the time and my Y is the distance. So this needs to be D equals minus 2T plus 32. I hope there are tons of comments of people being like, no, don't lose that mark. Okay, so, do I want to score this out? Let's just write it again underneath. D equals minus 2T plus 32. What a plot twist. Boom. Okay, so, let's go. What can I substitute in here? This is a time. So I'm just substituting into the right-hand side of the equation. This is going to be minus 2 times 14 plus 32, which is minus 28 plus 32. These have a difference of 4, so this is just going to be positive 4. Units. Sure. It's kilometers, right? Yeah. It's a 1 mark question. I don't think that they're going to care about the units, but might as well. 4 kilometers. Okay. Yeah! Time for some geometry. I'm looking forward to this one. So we've got a diagram shows a circle. Yay. AC is a tangent to the circle at point B. So that means that this is a right angle, this is a right angle. Cool. I've used this information. CE is a tangent to the circle at point D. You can have some right angles too. I've used this information. DG and BF are both diameters of the circle. Now, what information are we actually getting from that? Something fun to remember about circles is that all of the radii are the same. So any radius that you can draw on here is the same. Now I know that they've said that these are diameters, but that means that all of the lines that go from O to the edge are the same. So this one, this one, this one, and this one, these are all the same length. Okay, an angle DFE is 125. They already wrote that on there for me. Cool. Right, let's go. Eyes on the prize. We're trying to calculate the size of shaded angle BCD. This one in here. Okay, so game plan. I like to work backwards. First thing I notice is that this is a kite. So I have a kite in here, which is a quadrilateral. Now, there is a cool thing about kites in that this angle up here and this angle down here, now I'm second guessing myself. I want to say that they're going to add to 180, but that's specifically, it's because like, yeah, it's because these are 90 degrees. So in this case, they are going to add to 180 because they're both tangents to a circle. Okay, so that means if I knew this angle, I would definitely know this angle. But even if you kind of didn't think of it as these two together, you've got angles in a quadrilateral which will add to 360. You currently have 2 of them. One of them is the one that you want to find. You just need this third one. So if we could just get that angle, that would be great. Now, good news is this is on a straight line, and I know that's a straight line because it's a diameter. Yay, we're using the information. So if I could just work out this angle in here, I would have that. How am I going to get that angle in there though? Like there's no parallel lines, no F angles, anything like that. Well, I see that this is in an isosceles triangle. It's like in a triangle and then you can say, okay, that's isosceles. So, since it's isosceles, I only need one of like this angle and this angle is going to be the same. I only need to work out one of those and then I'll be able to work out the angle in the tip. But I can totally do that because I know that this is 125 degrees. So I can say that this angle in here is going to be 180 minus 125, which is equal to, what, 55? Fact check myself. Yep. Okay. Which means that this angle in here is also going to be 55. 55. 5 degrees. Cool. And so I might kind of start writing things at the side just to keep my working, it's going to get a bit too hectic on the diagram. So to work out angle DOF, what I'm going to do is 180 minus 110, because I know that both of these are 55. And so that's going to give me 70. So angle DOF is 70. To work out then angle DOB, that might be BOD, but it's okay. It's fine either way. So to work out angle DOB, I'm going to again have to do 180. Why did I give myself no space for this? Silly. Minus 70. So once again, it is 110. Okay, and like I might even want to put in there like angles on a straight line. This is so unnecessary. Angles on straight line. Okay, and then finally we're going to bring it home. So to work out the angle that we are aiming for, angle BCD. This is a mess. I've done this all over the place. Angle BCD is going to be, now how do I want to explain this? Oh. I think I'm going to go all out and I'm going to start with the full 360 of the quadrilateral. So quadrilateral, full 360, minus 90, minus another 90, minus the 110 that I know is up here. Okay. So that is basically 180 minus 10, which gives me 70 degrees. That's cool. I like that. Okay. Getting the marks in angles questions is notoriously, an absolute minefield. So, once again, we do not know the official marking scheme, but the best advice I can give is that if you are not marking something on the diagram, you need to be explicitly explaining what's going on, write your sums out, write out like what you're doing, and then if you have space, depending on like your writing size or whatever, it might even be worth going back and marking it onto the diagram. It is quite a nice big diagram, but yeah, like there's things like this right angle. How do they know that you know that the tangent forms a right angle? Like they can pick it up from the right angle on the diagram, or they can probably pick it up from the 90 degrees down here. But remember, when you're doing exams, you're playing a game of types. You're not just getting the answer. That's not the aim of the game. You are trying to convey that you know what's going on. So think about how you're communicating that. This working is a mess. Do better than me. Okay. So this is a good example of when there's way too much space for this question. Don't let that fool you. I think it's just a formatting thing, but an entire page for this question is not going to take an entire page of working. It's a 2-mark question. So we're thinking of like using 2 skills, maybe just doing 2 lines. I don't know why, but I love writing out the equation again. But that just depends on how much time you have in the exam. So we have the straight line in the general form x plus 4y minus 24 is equal to 0. I want to find the gradient of this line. Now, personally, my favourite equation of the line is y equals mx plus c. I think that has all of the information just right there for the picking. So I would like to rearrange this equation in the form y equals mx plus c. This is just like keep y as the target. You want to get y on its own. So we're going to like remove everything that's not y from the left hand side of the equation. So I'm going to add 24 to both sides. X plus 4y is equal to 24. I'm going to subtract x from both sides. So 4y is equal to 24 minus x. And then it looks like I'm going to have to divide by 4. So y is equal to 6 minus, and then this is invisibly 1x, so it's going to become like 1/4 x or x over 4, however you prefer it. And you might notice that this is a little swip-swappy in terms of y equals mx plus c. So I'm just going to move, risky business here, but I'm just going to swap these terms around, bearing in mind the negative belongs to the thing that comes after it. So this has to be y equals minus 1/4 x plus 6. And I can now compare this to my standard equation in the form y equals mx plus c. And be like, oh hey, look at that, m is minus 1/4. So you can say like gradient or m, they'll know what you mean if you write m, but the gradient is equal to minus 1/4. Coolio. Okay. Does that feel like two marks worth of work? I feel like I did a lot of lines of working, but I think that these two could be done in one line. These two could be done in one line, and the rearranging was actually unnecessary because you just need to identify the coefficient of x. So you could skip some of that out for sure, but not any of the thinking. You do all of the thinking. Okay, next page. Bring it. What have you got for me? Page 12. Oh, page 12, question 12. Page 10, question 10. Does this work out all the way through? Page 8, question 9. Oh, okay. Page 12, question 12. Express x squared minus 6x plus 8 in the form x minus a squared plus b. So this is completing the square, just basically putting it in the form. Yep, hiccups. Am I going to go through? Right, so there is some nice understanding behind why this is what it is, but in this amount of space, for this amount of marks, all I'm going to say is a is going to be half of the coefficient of x, so you're just going to have x minus, now the coefficient here is like minus 6, so that's going to become minus 3. Sometimes there's no qualms here with the signs, the plus and minus. This is negative, it's all good. So we're going to have x minus 3, I've halved it, squared, and then I kind of think to myself, okay, if I did square this, what would I get? I'd have x squared minus 6x plus 9, but I do not have plus 9, so I'm just going to compare the constant term at the end. I don't have plus 9, I've got plus 8. So how do I fix that? I minus 1. So many different ways of doing this, but what I would say is, like, once you've got your completed square form, and very likely you're just going to have a mark for having what's in the brackets correct and a mark for having the b term correct. Please, 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 please do not forget to put the squared at the top. Yeah. Like, once you've written it down, just multiply it out, either physically, like actually do it to the side, just kind of say, okay, what is x minus 3 squared? Well, that would be x minus 3 times x minus 3, and then I'm going to have a minus 1 at the end, so yeah, that's going to give me x squared minus 6x plus 9 minus 1. Yes, that does give me x squared minus 6x plus 8. Like, yay, tick, everything's kind of working out. You can check in for yourself in the exam that it's all working, if you like. But yes, we've done it. We've completed the square. Okay. Hence or otherwise, state the coordinates of the turning point of the graph of y equals x squared minus 6x plus 8. We have seen this before. Cool. So this is just 1 mark. You just need to state the turning point. The thing to remember is that brackets work backwards. Brackets backwards. And so what is inside the brackets here is a shift in the x direction, left or right. It so feels that minus should move it to the left, but it doesn't. It moves it to the right. And so whatever the sign is in the brackets, just make that backwards. minus 3, that's going to become plus 3. And then thing at the end, that is a shift, like moving this parabola either up or down. In this case, it's moved down. That's going to be minus 1. You basically take a and b. Actually, I don't know why I'm making this so complicated. I can give you a general formula for it. The turning point is going to be minus a b. Whatever's here, flip the sign. Whatever's at the end, don't. Okay. Next. The diagram shows the graph of y equals x squared minus 6x plus 8. A line PQ has been drawn parallel to the x-axis where P lies on the y-axis, okay, so that's our y-intercept. P and Q lie on this line here. Find the coordinates of Q. Okay, I feel like the key to hunting this down, let's see, little highlighter. The key to hunting this down is remembering that all of the points on this line are going to have the same y coordinate. But this point in particular is the y-intercept. And on the y-axis, x equals 0. Like, you want to have that snip-snap ready to go in your head. X-axis, y equals 0. Y-axis, x equals 0. But you can think through it, like, you know, what's this point? 0, 1, 0, 2, 0, 3, 0, 4, whatever. So, on the y-axis, the x-coordinate is always 0. So I think we can work out full on what p is, because I know that the first part of that coordinate is 0. So all I'm going to do is substitute. Can you still see this? Oh no, low battery. We might have to hustle. Okay, so all I'm going to do is substitute x equals 0 into y equals x squared minus 6x plus 8. You do not have to write that. You can just be like, oh wait, this is 0, this is 0, y is going to be equal to 8. Okay, we got it. Okay, so that means that this point here, Q, I don't know what the x-coordinate is, but I do know that its y-coordinate is 8, because all of the points on this line have a y-coordinate of 8. So I can then substitute y equal to 8 into the equation for this line, because this is telling me, hey, do you want to find, well, it's like, do you want to find the x or the y coordinate? Here's how they relate on this line. So into y equals x squared minus 6x plus 8. Okay. I am going to write this backwards just for fun. So x squared minus 6x plus 8 is equal to 8. Oh my gosh, if I take away 8 from both sides, they're going to cancel out. So I get x squared minus 6x is equal to 0. The only way to solve an equation where you got x squareds and x's is to factorize. But look at this, because the 8's cancelled out, we're just going to take a common factor out. Yay! So we're going to have x, and then in the brackets x minus 6. Equals 0, and the only way you can have two things multiplied together to give you 0 is if one of them is 0. So either x is equal to 0, which is this point here, or x is equal to 6, which is going to be this point up here. Now, the question says specifically find the coordinates of Q, so make sure that you have written down the actual coordinates of Q. It's 6, 8. Okay, how many more questions have we got to go? We've got 2 questions, and I have 10% battery. Let me see if I can very quickly find a charger. Oh no! Please bear with for this brief interlude. Charger? Okay. 43 minutes, oh man. Fair play if anyone's managed to watch for this long. Make sure you're eating plenty of snacks and taking breaks and looking after yourself and loading up on probably water or whatever beverage of your choice. I'm not sponsored by Iron Brew, but I do love